Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at Demovires theorem, in which we are going to simplify the expression of this, find the modulus and the argument. The argument is just the angle. Then we are going to simplify this. So let's begin with simplifying this one. So now, one thing that you need to know is that if you are looking at the cosine of theta is an even function. So if you recall what we refer to an even function, it means to say if you press on your calculator, the cos of 60 degrees is equal to the cos of the negative 60 degrees, like that, which should be equal to positive 1 over 2. That's the meaning of an even function, meaning to say even if this one is negative, this one will produce the same answer as the positive version. So now this is important when you are simplifying. Also, if you have the sine of 60, if you have the sine of negative 60 degrees like this, sine is an odd function, meaning to say the negative of that angle will be equal to negative the sine of that angle positive, like that. So that is the main difference. So this will be the root of 3 over 2. Don't worry about how you get this. We have looked at this, but this is not important in how you get these values for Demovires theorem. All I wanted you to pay attention to is how sine is an odd function, meaning to say the negative will be the negative of that trigonometric ratio, whilst the positive of the cos will be the negative of that cos. Now, with that said, that is how we simplify Demovires questions or problems. So in this case, if you look at this one, now if you look at this one, the cos, we just need to make sure. Now if you remember what we looked at, if let's say you have a number here which is 2, if you have, let's say, the power 3, if you recall from the previous video, if you have the power 3, this power 3 can come here, which can be 3 like this, another 3 here. Now, likewise, if that is true, that means to say when it comes there and it comes there, it simply means to say this one no longer is there. So that means to say this one you can reverse it and put it on top here, provided that the number here on cos and the number here on sine is the same. That means to say you are allowed to do that. So with that said, that is what we are going to be doing. So in this case, if you have the negative here, you need to make sure that the one at the bottom and the top are the same. So what are we going to do? So push this negative here and make this negative. So we are going to have the cos of negative, just think of negative 1 pi over 7 like that. Then we have plus our I sine of negative pi over 7. But remember, there's an invisible one there. So now this means that we are going to have our power of 3. Now, I haven't changed anything by putting negative pi over 7. Why? Because cos is an even function, meaning to say the negative is equal to its positive, like that. Then what this means is that we have over our cos of pi over 7, then plus our I sine of pi over the 7, like that. So what does this give us? What power do we have? We have power 4 here. There we have power 3. So what we are going to do now is the negative 1 is common here, meaning to say we are going to push this negative 1 up there. You must make sure that it is the same number on cos and sine. So this one will be pushed there. So this will be your cos of pi over 7, like that. Then we have our plus our I sine of pi over 7, like that. Then this value will be raised to the power of, we have our negative 1 by the number 3, like that. Then we divide this value by our cos of pi over 7 plus our I sine of pi over 7 like that. Then we have our 4 like that. So this gives us cos of pi over 7 plus our I sine of pi over 7 like that. Negative 1 by 3, it will be negative 3 like that. Then we divide this by cos of pi over 7 plus our I sine of pi over 7 like that. Then to the power of 4 like that. Now remember laws of indices. If you have, let's say, x times y, or should I say, sorry, not x times y, x times x, this is equal to, you take one base and add the powers. So this is 1, this is 1, so it will be x 1 plus 1 like that. But if you are dividing, let's say, x to the power 2 over x to the power 1, it will be, you take one base, then subtract the powers. So it will be 2 minus 1. So that is basically how we do this. So it will be x to the power 1 like that. Now if that is the case, that means to say, as long as the two equations are the same, you are going to take one base and subtract the powers. So you are going to just take whatever is at the top, since it is the same with this one. So you are going to say cos of pi over 7 plus our I sine of our pi over 7 like that. Then it is power negative 3. Then we have minus 4 like that. So this gives us our cos of our pi over 7. Then we have plus our I sine of our pi over 7 like that. Then it will be power negative 3 minus 4. It will be negative 7 like that. Now we are not done. If we have simplified it, that simply means to say just retain this value there. So it will be the cos of negative 7 by pi over 7 plus our I sine of this 7 comes there. It will be negative 7 by pi over 7 like that. So this is what we have. Negative 7 by negative 7, it will be able to cancel. Then we have our cos of, we have our negative by 1, it will, by pi, it will be negative pi. Then we have plus our I sine of our negative, so this one and this one, it will be negative pi like that. Then what do we have? Remember, cos is an even function, therefore this will just be cos of pi like that. Then sine is an odd function, so this negative will come there, so it will be a minus I sine of pi like that. Now remember the values of the sine of pi and the cosine of pi. It's like this. So remember, if you're looking at the graph of sine, remember, just think of sine as being real, meaning it will start at 0, go up, come down like that. So this will be your 90 degrees. Then this one will be your 180 degrees. Then the middle point will be 270 degrees. Then this one here will be equal to 360 degrees. So pi, 90 is pi over 2 if you recall. 180 is equal to just pi. So we are just interested in this value. So for sine, it is equal to 0. So sine of pi is equal to 0. That's the meaning. So this gives us, then the cosine of pi is, cosine, think of it as being a line. Instead of starting here, it starts there, comes down, goes up until your 360 there. So this gives us a 90, this gives us 180, this gives us 270, this gives us our 360 like that, 360 degrees. So 180 is corresponding with negative 1. So we are going to say the cosine of 180, which is a pi, is equal to negative 1. So that is how we evaluate. Cos of pi is equal to negative 1 like that. Then it will be minus I. The sine of pi is 0 like that. So this is what we have. We have -1 plus 0i. You can even end here, or if you want you can say this should be equal to -1. Now let's look at the other one. So looking at this, we just have to strategize. So as you can see, we already have pi over 3 here, pi over 3, we have pi over 3, we have pi over 3, pi over 6, pi over 6, like that. So what are we going to do? So we leave this one the way it is, so it will be cos of pi over 3, like that. Then we have plus our I sine of our pi over 3, like that. Then this power is equal to the power of 5, like that. Then we are going to say it will be our cos of our pi over 3, like that. Then we have minus our I sine of our pi over 3. Now what we have done is that we have gotten this to remember the rule of Demovires theorem. It can be thrown out, but it's finding a 4 there, so it will multiply like that. Then we divide over our cos of pi over 6 minus our I sine of pi over 6, like that. Then this as the power of 2, like that. So let's deal with the top first. So now what are we going to do? So we need to convert this negative into a positive so that they match up there. So we have our cos of pi over 3 plus our I sine of our pi over 3, like that. Then we have, this is power 5, like that. What do we have? We have our cos. Cos is an even function, so even if we add the negative, it doesn't change anything. So that we have negative there. Then we have our positive I sine of, let me reduce the font and move it. So this gives us our negative pi over 3, like that. Then the power is equal to the power 2 times 4 is 8. So we have power 8, like that. Then this divided by, what do we have? We have the cos of, now what we are going to do is that since we want it to have 3, you know that when you multiply 2 there, when you have pi over 6 by 2, it will reduce to 3. So we are going to make this 2 go inside there, so it will be our cos of our 2 by our pi over our 6, like that. Then we have minus our I sine of 2 by pi over 6, like that. So this is what we have at the bottom. We just want it to be comparable. So now what we're going to do is that this -1, we're going to throw it out. So it will be, for the first part, it's the cos of, let me just grab it. So this -1, we are going to throw it out. We're going to throw it out, and it will find the 8 there. Then we divide over this one. We are going to have cos of 2 divided, here it will be 3, here it will be 3. So this gives us the cos of pi over 3. Then we have minus our I sine of pi over 3, like that. So this is what we have. Now when we do that, we are going to deal with the top now. So we have our cos. Okay, so -8 by, you can write it as your next step, -8 by 1, it will just be negative. +8 by 1, it will be -8, like that. Then from here, what you're going to do is you pick one base. So let's pick this, since they have the same things. So you pick one base like that, and then you add the powers since you are multiplying, but that one is negative. So now when you pick this, its power is 5 like that. You add the powers, so you say plus, but the number is -8. So whether negative by positive, it's negative, so that's why we just subtract. But in the actual sense, we are adding, so it's -8 like that over. Now make the bottom as well be the same, having this sign. So this will be cos of -pi/3 like that. Then we have our positive I sine of -pi/3 like that. So this is what we have at the bottom. So our 5 minus 8 is -3. So the top, it will be cos of pi/3 plus our I sine of our pi/3 to the power of -3 like that. At the bottom, what we have is this -1. So this is the same as having to the power just 1. So this -1 is going to be thrown out, and it will find this +1, so it will be a negative. So we are going to say cos of pi/3 minus or plus I sine of pi/3 to the power of -1 like that. So the bottom and the top are the same now. We are just going to pick one and subtract the powers. Since we are dividing, you subtract the powers. So this gives us cos of pi/3 plus I sine of pi/3. We have -3 minus, then we have a -1. Just be careful there. So it's cos of pi/3 plus I sine of pi/3 to the power of -3 plus 1, which will be cos of pi/3 plus our I sine of pi/3 to the power -3 plus 1 will be -2 like that. So now all we have to do is, after you're done with this, just bring the 2 again, let it enter inside. So it will be 2 comes there, 2 comes there. So it will be cos of -2. It finds pi like that. We also have plus our I sine of -2 pi/3. Now remember, cos is an even function, so its value will be positive, so it's 2 pi/3. Then sine is an odd function, meaning to say the negative will be pushed out, so we have the negative sine of 2 pi/3 like that. Now we need to finish this. In this case, we need to know what this angle is equal to. So remember, 2 pi, just in case they are asking you to find the argument is the angle, so it's 2 pi/3. The value of the radius or the absolute value would be 1, because this number is surrounded by 1. We are going to solve that last question, but now you need to know what this angle is equal to. So remember, if you're looking at 180 degrees, it is equal to pi. But how about 2 pi/3? This is equal to x. You cross multiply pi by x, it's pi. X should be equal to 180 by 2 pi/3 like that, so that this and this cancels. You are going to have 60 like that. So your pi should be equal to 60 by 2, it will be 120 pi like that. Pi x, you divide by pi on both sides, so this gives us our, so this that is pi. X is equal to 120 degrees. So remember the knowledge of reference angles. That means to say 120 degrees is here. You go like that. So this is 120 degrees. So if this is 120 degrees, the remaining angle from the x-axis and the terminal side, it is equal to 60 degrees like that. Now if you recall what your angle of 60 degrees is equal to, the special triangle, I'm always stressing this fact. You have 30, the one closest to 30 has to have a 3 because both have 3 there. You can use that to remember. This is your 60, this is your 2 like that. 1, 2, root of 3 like that. Now, if you look at the cos, the cos is equivalent to, the cos of 60 is equal to adjacent like that, which is this side, over the hypotenuse, which is 2 like that. Now, since it's in the second quadrant and cos is negative, so whatever you take as your angle, remember the cos of theta is equal to adjacent over hypotenuse. In this case, adjacent is the base, which is 1 over hypotenuse, which is a 2. But since it's in the second quadrant, it will be negative. So this gives us our value, which will be equal to cos of 2 pi over 3 will be negative 1 over 2. Then we already have a negative there, so it will be minus, but the sign of 120 is positive because sign is positive in the second quadrant. So sine of 60 is equal to opposite, which is the root of 3 over the hypotenuse, which is a 2 like that. So this is how we deal with such a question. Then, so this is what we have. So this is our answer for that problem. So let's look at this. So this 4 affects this one. So this one and whatever is in the bracket there. We are looking at the modulus and the argument. So the modulus is just the absolute value. So in this case, we are looking at this number raised to that. Now, if we are to write this, we are going to say the square root of 3 like that. Then we have the cos of pi over 6 plus our I sine of our pi over 6 like that. The power is 4 like that. Now this 4 is affecting everything there. Then down here we have our cos of pi over 4 minus our I sine of pi over the 4 like that. Then this is to the power of 4 like that. Is it 2? We have the power 2 there. Now what we are going to do is that this 4 affects this, but square root of 3 is the same as 3 to the power half like that. Then we have power 4 like that. So this gives us our cos of pi over 6 plus our I sine of our pi over our 6 like that. Then it is raised to the power 4, so the 4 is distributed like that. Then what we have is remember, okay, so let's just deal with it direct. This negative there, let's get rid of it, so it will be cos of negative pi over 4. Now what I'm going to do is this. I can even write my negative 1 over 4 there. So it will be negative 1 over 4. I haven't changed anything. Whether I write like this or I write like this, nothing has really changed. So knowing that in mind, we are going to have the negative of 1 over 4 like that. Then we have plus our I sine of our negative 1 over 4 like that, pi. Then we have to the power of 2 outside. Now our aim, in order for us to more like have the same things, we just need to leave pi alone, because that is the only way we can have the similar thing. So even the one on top, without wasting time, since you now know what we are doing, we are going to do the same thing. So let me just increase it. So increasing it means it will look like something like this. Now what we are going to do is that it will be 1 over 6 pi and also 1 over 6 pi, 1 over 6 pi like that. Then this one is to the power of 4. So this is what we have like that. Now all we have to do now is just take this value outside and take this value outside. That means to say that we are going to remain with pi. So let's begin working here. This and this cancels. We are going to remain with 2 there. So this is going to give us 3 to the power 2 by our cos of, it will just be pi like that, plus our I sine of our pi like that, to the power of, we have our power 4, then times this 1 over 6, since it's thrown outside, 1 over 6 like that. Then we have over our cos of pi like that, plus our I sine of our pi like that. Then this to the power of 2 times negative 1 over 4 like that. 3 to the power 2 is 9. Then we have the cos of pi like that, plus our I sine of pi like that. Then this to the power of 4 divided by 2 by 6 is 3 here. Here it will be 2. So it will be 2 over 3 like that. Then down here we have our cos of pi plus our I sine of our pi like this, to the power of this and this goes, so we have 2. So this gives us negative 1 over 2. Then 9, we take one base, since they are the same now, it will be cos of pi like that, plus our I sine of our pi like that. Then this will be to the power of 2 over 3 like that. Then we have minus our negative 1 over 2, since we are dividing, it will be minus. So it will be 9 cos of pi like that, plus our I sine of pi to the power of 2 over 3. Then it will be plus 1 over 2. So it will be 9 cos of pi like that, plus our I sine of our pi to the power of the common denominator that 3 and 2 can enter is 6. 6 divided by 3 is 2, times 2, that will be 4. 6 divided by 2 is 3, by 1 that will be 3. So this gives us this. So our 9 cos of our pi plus our I sine of our pi to the power of 4 plus 3 is 7 over 6 like that. Then all we have to do is let this 7 return there, so it will be 9 by our cos of 7 pi over 6 plus our I sine of 7 pi over 6 like that. So from here you can be able to more like put your angles. So the modulus in this case, the modulus is equivalent to the number outside, which is your 9. Then the argument, which is just the angle, which should be equal to 7 pi over 6, like that. So for such a question you end there, but if you are taught to simplify, so this is where you end. If you are taught to simplify, you just have to find what your angle is. You can say 180 degrees is equal to 2 pi. How about if you have your 7 pi over 6, this is equal to x. You cross multiply, it will be pi x should be equal to 180 degrees times our 7 pi over 6. So this one and this one cancels. So 18 divided by 6 is 3, 0. So we have 30. So our pi x is equal to 30 by 7 pi like that. we divide by pi, we divide by pi, this and this goes, so this gives us x is equal to 30 by 7 is 210 degrees, like that. So 210 degrees, you do the same. So 210 degrees will be here. So that means to say, if from here up to here it is 180, it means to say the remaining for it to be 210 has to be 30. So this has to be 30 degrees. This has to be 180 degrees, like that. So that is basically how you are going to do that, and use your special angle, knowing fully that cos and sine are negative in this quadrant. You can be able to evaluate such a value. But anyways, let me just finish it in case such a question came to express, but if they just want the argument and the angle, you end there. So this means that if you have your 30 degrees, remember your special triangle. So your special triangle, the one closest to root 3 is 30. Here we are going to have 60 degrees. Here we have a 2. Here we have a 1. So the one that is opposite for cos of this one, it will be cos of 7 pi over 6. It will be negative because it's in the third quadrant, and in the third quadrant cos is negative. So we have 9 by, it will be cos of 30 degrees is adjacent, which is root 3 over 2, like that. Then we have plus our I. Is it plus or minus? We have plus our I, sine of 7 pi over 2. So the sine of 30 is opposite, which is 1 over the hypotenuse, which is 2, but it is in the third quadrant. Therefore, it will be by a negative 1 over our 2, like that. So this gives us 9 by our negative root of 3 over 2. 9 is multiplying everything, so it will be by 9i times negative 1 over 2. So the final answer for this would be negative 9 root of 3 over 2. If they told us to simplify, then we have minus our 9i over 3, like that. So this could be our answer for that. Thank you very much for watching. Hope you could like, subscribe, and share for more. See you in the next tutorial.